Oh, I'm Arthur. Welcome to my lab. In last video, I mentioned that I will talk about the bushings that I use on my Hypercube X carrier. So here they are. These are the bushings. They're very similar to the original design. However, I modified them to actually include the bushing itself in the holder, the external shell. So I don't know if you can see this, if I can make a good close-up, but this is the shape, the inner shape of this bushing. It has these thin walls which basically flex as they move up and down the shaft and conform to the shape of the shaft and form a bushing. So here's 9.5 millimeter roughly aluminum rod. This is actually US 3/8 of an inch rod. That's what I was able to find. I was looking for a 10 millimeter aluminum rod or tube everywhere, and actually I ordered one from China, but it was taking forever to arrive. And so in the meantime, I just went and bought a rod like this, and that's what I'm using in my printer. By the time the rod that I ordered from China arrived, it turned out that it was packed in like a couple of layers of thin bubble wrap, and it got all bent and damaged in the shipping. So it's great that I went with these locally sourced rods anyway, because that rod from China would be of no use. So anyway, that's the 3D printed plastic bushing that I'm using in my printer, and it slides pretty smooth and nicely. This is 9.25 millimeter size. That's the setting that I used to print this one. I've also tried 9.5, 9.75 millimeter, and just went with the one that fit best the shafts that I have in my printer. So you can print several of these and just adjust the size and see which one works the best. And by the way, the original design of this inner bushing, that shape, that design was made by Trifid Hunter, and on my Thingiverse page I post a link to the original design along with a bushing. I posted 3 sizes of these bushings, so you can pick from 9.25, 9.5, and 9.75 millimeters, which one of these should fit US size 3/8 aluminum rods. So that's one thing that I wanted to talk today about. And the other thing that I forgot to mention actually in the last video was that one other change that I made to my X carriage is I made the bottom flat. Originally, the bottom has these 2 bumps in it, and that's probably just to save the weight, you know, minimize the weight of the carriage. So this surface doesn't need to reach all the way up to here. It just needs to encapsulate these 2 nuts or screws. But I wanted to have the bottom of the carriage flat, because then I can use these LED strips, just put them on the bottom of the carriage, and I have a very nice light shining on my print, and it helps me to see how my print is going. So that's a nice enhancement. I really liked how that worked out. So that's something that I forgot to mention in the last video. Now, the next thing that I'd like to talk about is somebody asked me about the extruder that I use in my Hypercube printer. And so these are the parts that you need to build the extruder, and this is a completed extruder. Here's the whole module, the whole assembly. It's a belted extruder. You can use any smallest motor that you have, because thanks to the gear ratio here between the small pulley and the big pulley, you get a very nice increase in torque. So even a small motor with a small torque will work just fine. And original design, I think, used 20 tooth pulley for the motor and 60 tooth pulley for the belt shaft. or the bolt, hubbed bolt, I changed that to use 16 teeth on my motor and 17 teeth on my bolt. What this does is it allows me to have a lot more resolution when printing. I can print much more precisely or extrude the plastic much more precisely because there's more steps required for one revolution. And also it improves the torque ratio as well. So you can get away with using even a weaker motor than the original design. The great thing about this extruder is that once you adjust these springs to have the right tension, you don't really need to readjust your extruder when you need to change the filament or do anything to open up the path of the filament. You just basically squeeze this part, lift it up, open up this part, and you have access to your hubbed bolt, your filament. You can clean the teeth if need be, although my extruder has been running for hours upon hours and I did not have to clean the teeth on the hubbed bolt yet. So it's fantastic. And then to feed the filament, all you need to do is, let me back this filament out. Alright, it's taking a while. There we go, almost there. So you just stick your filament in from the bottom, feed it to the other side, push it a little bit on the top side to guide it into the upper hole towards the exit of the extruder. Then put this part back on and you're all set. You can use your printer to feed the extruder, the filament out of the extruder. So that's how this thing looks like assembled, and here are the parts that you need to build this extruder. You need GT2 belt, and original design used 180 millimeter GT2 belt. I've changed my design to use the 200 millimeter belt because that's what I had on hand. So basically I made this part longer, I extended this part, and this allows me to use 200 millimeter belt, which original design, the author actually says that you cannot use this belt with his design because it just won't fit. So I had to extend this part. This is the 70 tooth pulley that I created. So I'll post this one online along with this shell in case anyone wants to use a longer belt. Again, any stepper motor, NEMA 17 sized will do. This is the smallest motor that I have. That's the same motor that's sitting in my Hypercube, and it's working hours every day, and it just runs incredibly nice. These are the two plastic parts through which the screws go, and this is where the 608 bearing goes in to push on the filament. So these 5 parts is what you need to 3D print. You also need 2 springs, and you'll just have to figure out which springs will be the best fit and which ones will work the best for you. 2 M3 nuts, 2 M3 50 millimeter bolts, and 3 608 skate bearings. I'm not going to get into how to assemble this extruder. It's really simple, but I just wanted to show you the extruder that I'm using on my Hypercube, and I can testify to the fact that it's working really nice and it has no problem extruding filament for hours. I think the longest print so far that I did was 7 hours, and then when that one was done, I just picked up my parts off the bed and started another 5-hour print. So it works great. So that's what I have for today, and see you at the next video.